Hey guys, this is Coach Brian bringing you your Unit 7 test review. This test, at least for this school year, not if you're watching this in the future, but if you're taking it this school year, your test will be Monday and Tuesday, the 30th and the 31st. All right, let's get right into it. For question number 1, they give us the transformed function. All right, we've been working primarily with cosine and sine, and we have our different values here. So you really need to know this like original function so that you can put everything in the right order for later questions. So you really need to know this. But you also need to know what the letters do. So K, which we've been putting out front, K changes our vertical shift, and that's really responsible for moving the midline. It moves the midline up or down. Both of our parent functions have a midline of 0. So if you move up, it'll be a number greater than 0. If you move down, it'll be a number less than 0. A, the number right in front of the trig function, controls the amplitude. Essentially, that's going to make the graph the peaks and the valley, or peaks and valleys, crests and troughs. It makes the graph taller or shorter. Again, the parent functions have an amplitude of 1, so anything more than that has been amplified, and anything less than that has been kind of shrunk through the amplitude. All right, B is the number right in front of the angle. B is a wave's frequency, and it is going to change the period. So I would say it modifies the wave period. And we use it, if we are using degrees, we would say 360 over B equals the period. If we are using radians, we would say 2 pi over B. 2 pi over B. Our H value, which is in the parentheses with our angle, it's responsible for our horizontal shift. Or when we're talking about waves, what we call a phase shift. It's going to move our starting point left or right. So I would say that it adjusts the X values. It's going to either move your starting point to the left or to the right. For 1D, it says, what is the total vertical distance? Well, total vertical distance is the total distance covered from the lowest point on your wave up to the highest point on your wave, the vertical distance. So wave height has all to do with amplitude. And so we would say that the vertical distance equals the absolute value of 2 times the amplitude. So let's say you have an amplitude, I'll do a little example over here. Let's say you have an amplitude of -3. If you have an amplitude of -3, your vertical distance would equal the absolute value of 2 times -3. So the absolute value of -6, which is 6. So that's how you can find your amplitude or your vertical distance, depending on which one you are given. For 1e, it asks, what is the domain? And we know that for all of these sine and cosine graphs, the domain is always all real numbers. We need to put that correctly into interval notation. So we don't use the letter A for all real numbers. We can eliminate those two answers. We use the infinity symbol, okay? Now, we know it goes from negative infinity to positive, and the difference comes down to we want to use parentheses because you can never actually include infinity. Brackets mean included. There's always another number when you're talking about infinity. There's always a number higher or one more number lower. So you can never actually include infinity. For questions 2 through 5, it says sketch 2 complete cycles of each graph and label all critical points. I like to start these problems by labeling K, A, B, and H, and also just underlining my trig function. And if they tell me what I'm working in, which is degrees, that's helpful too. All right, so we are gonna start with the trig function. It is a cosine function. If I look at the sign in front of the A value, it is positive, which means my graph has not been reflected. And if it's a cosine graph that hasn't been reflected, that means it's going to start high. And once I know it starts high, I can go ahead and map out my middle, low, middle, high, middle, low, middle, high. And once I have all those critical points, let me fix that one a little bit. Once I have all of these critical points, I can actually go ahead and connect them using my smoother curved lines to create my cosine wave, my sinusoidal wave. All right, I don't love that part, so I'm going to clean it up. Now we have our wave, but we don't have any values on here. So next thing I like to do is look at the vertical shift. Vertical shift, this has a K value of 5, so it's been moved up 5. And like we said earlier, that controls our midline. So that means my middle line on my y-axis is going to be 5. Next, I like to look at the amplitude. This has an amplitude of 3. I got that from my A value. That means the maximum number will be 5 plus 3, and the minimum number will be 5 minus 3. So I've got my max and my min right there. Now, you don't have to do it in this order, but once you have these three numbers, you can go ahead and answer the range because it's going to go from the lowest to the highest. You can also figure out the total vertical distance because if I go from 2 to 8, that's a distance of 6. And then the last thing is this is a cosine graph, so I know the domain is all real numbers. Next, if we look at horizontal shifts, that's going to be what's in the parentheses right here. That's going to be what's in the parentheses, my H. It's a plus 5. This is the one that does the opposite of what you would think, so it's going to move us left 5. Our period, since we're working with degrees, is going to be 360 divided by B. B is 10. So our period for this wave is going to be 36. And our critical points are going to be the period over 4, which is 9. So let's label our x-axis. Normally, this graph would start at 0. But now we've been moved to the left 5. So if you think about what number is 5 to the left of 0, it is -5. And from there, every block or every tick mark goes up 9. So -5 plus 9 is 4, plus 9 is 13, plus 9 is 22, 31, 40, 49, 58, 67. Now we have everything marked, every critical point is labeled, everything on our y, everything on our x. So we're done with this question. You'll do this exact same process on 3, 4, and 5. I'll still work them. I'm just going to work them a little quicker. Number 3 is a sine graph. Sine graphs start in the center. If you look at the sign, positive or negative, in front of your A value, that'll tell you if you're reflected or not. And in this case, since it's negative, we have been reflected. What that means is our graph is going to start by going down. So alternating middle high, middle low, we can go ahead and map out the remaining critical points. And then once they're in place, we can connect them all. Sorry, did that backwards. There's our sine wave. Now, our K value out front tells us that we've been moved down 4. And that's going to affect our midline. So we would have been at 0, but now we're going to be at -4. Our amplitude is 2. That means my top number is going to be 2 greater than -4, and my minimum will be 2 less than -4. You have to be really careful when you're working with negative numbers. Horizontal shift comes from the parentheses. This has been moved left 250. Right 250. Like I said, it does the opposite of what you'd think, which means I'm going to be starting at 250 instead of 0. My period is going to be 360 over B. B is 1/3. So I'm going to flip that. And I'm going to do 360 times 3 over 1, which is 1080. Critical point, going to be period over 4. 1,000 divided by 4 is 250. 80 divided by 4 is 20. 250 plus 20 is 270 degrees. 270 degrees. Now, I have all of my information, so it's time to fill in some of the points here. Vertical distance. If I go from -6 up to 2, that's a vertical distance of just 4. And my range, again, this can be confusing with negative numbers. You have to pick the lowest, which is -6, and then you're going to go up to the highest, which is -2. My domain is all real numbers. I've got my y-axis labeled, but I don't have my x-axis labeled. So, keeping in mind that I start at 250, and every critical point is going to be 270 greater than that, I'm going to jump from 250. I'm going to jump up 270, which is going to bring me to 520. I'm going to jump up 270 more, which is going to bring me to 790. Jump up 270 more, which is going to bring me to 1,060. Going to jump up 270 more, which is going to bring me up to 1,330. Plus 270 is going to bring me to 1,600. Plus 270 is going to bring me to 1,870. Plus 270 is going to bring me to 2,140. And plus 270 is going to bring me up to 2,410. You might want to double check me on this because I'm doing it all mental right now. The distance from your starting point to your end of your cycle should be 1080. If you take 1330 and you subtract 250, the answer is 1080. If you take 2410 and subtract 1330, the answer is 1080. So it looks like we did everything correctly. For question number 4, we have a sine function. Since it's sine, I already know it's going to start in the center. I'm going to look at the sign in front of the a value, and it's positive. So this has not been reflected, which means my graph is going to start up. Once I know it's going to start up, I can go high, middle, low, middle, high, middle, low, middle, and I can trace out all of my connections. So there's my wave. My vertical shift comes from K. It's been moved up 8. That's going to affect my midline. My amplitude comes from A. It's 2. So that means from my midline to my top value will be plus 2. My bottom value will be minus 2. Horizontal shift is negative 3, which means I've moved to the right 3. Period is going to be 2 pi over b. I'm going to need to flip that. When I have a pi in the numerator and the denominator, they will cancel, and 2 times 6 just leaves me with 12. Critical points will be period over 4. 12 over 4 equals 3. So let's think this through. I've moved from 0 to the right 3. So instead of starting at 0, I'm going to start at positive 3. Next, every critical point is 3 apart. So it'll be 3, 6, 9, 12, 15, 18, 21, 24, and 27. Each period should be 12. From 3 to 15 is plus 12, and from 15 to 27 is plus 12. So that checks out. My total vertical distance comes from these numbers on my y-axis. It comes from going 6 to 10. Gives me a vertical distance of 4. Gives me a range of 6 to 10. And I have a domain of all real numbers. Moving on to 5, I have a cosine graph. The sign in front of A is negative, so this has been reflected, which means it's going to start low. Once it starts low, I can go middle, high, middle, low, middle, high, middle, low. And I've got all my critical points plotted and now ready to connect them. All right, now let's actually put some values on here. We have our K, A, B, and H. K tells me that I've moved up 14. That's going to make my midline 14. A tells me I have an amplitude of 20. That means my top number will be 20 higher, and my lower number will be 20 lower. 14 minus 20 is -6. My horizontal shift, I've been moved plus pi, which means left pi, which means instead of starting at 0, I'm going to be starting at -pi. Period's going to be 2 pi over b, which is 2/3. When you flip that, it gives you 2 pi times 3 over 2. Look what happens to the 2's. They cancel out. So I've just got pi times 3, which is 3 pi. Critical points will be period over 4. 3 over 4 can't be reduced, so I'm going to leave it as 3 over 4. Now, my period is 3 pi, which means from line to line or cycle to cycle should be plus 3 pi. Well, I start off at -pi, so if I have a -pi and I add 1, 2, 3, that brings me up to 2 pi. And if I add 3 one more time from 2, that will bring me up to 5. Now, to get all the points in between, I need to look at my critical point value, 3/4. 3/4. That's what every one of these lines is. So you can do this a number of ways, but maybe it's easier to work backwards. You have 2, you take away 3/4. That leaves you with 1 1/4, also known as 5 pi over 4. Take away 3 more, that brings you to 2 pi over 4. Take away 3 more, that brings you to -1 pi over 4. Work the other way, you've got 8 pi over 4. Add 3, that brings you to 11. Add 3, that brings you to 14. Add 3, that brings you to 17. Add 3, that brings you to 20 pi over 4. And that looks like everything. Our total vertical distance, remember, it's the absolute value of 2 times your amplitude. So for us, that's going to be 2 times 20, which is 40. Domain's all real numbers. Range is from our lowest number to our highest, all included in the graph, so we're going to use brackets. Thanks for watching this first section. I'm going to break it into parts because this video will be crazy long if I don't. So make sure that you look for part 2 for the continuation of the video.